Hello viewers and welcome to Inverse Functions. Really lovely having you here. We're actually following the Cambridge Essentials course for this particular set of videos, so that's an Australian thing. I wonder whether it's in the UK, I don't know. Maybe it is, maybe it isn't. But for those of you who are following along, this is dealing with work on exercise 5G. Those are the questions that I'm recommending to be done. All right, that's over to you to do. If you're watching into land and just have nothing better to do over a weekend or an evening, it's really good to see you. Now, most of my videos, I've done a recap where I've scribbled in the margins and sort of talked over things. Please remember that function notation is where you have a domain mapped onto a codomain and you have a function of x is equal to, let's just say x plus 3, make it a straight line. So what it means is this describes a function, a line that is x plus 3. So that's going to go through 3. And it is limited between the values of 0 and 4. So before I even go any further, there is no graph there. So I would only have the values between 0 and 4. It's mapped onto this codomain. I say it over and over again, just write it, okay? In university, it gets different. You map onto all sorts of different things, but for methods, it just has to map onto real. Every single function, not relation, every single function you define in methods, be it in a SAC or your exam, I cannot impress enough, has to be in this form, okay? That's one thing. Last lesson we dealt with hybrid functions and what was it? Wow. Applying function notation. That's awesome. Applying function notation. Really important. But today we're doing inverse functions. Now I have to say this comes up in methods 3 and 4. And it to this day surprises me that people don't giggle along with hysterical excitement when they see the word inverse function, because there's only 2 things to it. And it really worries me that people find it hard. All right. I'm really sorry. Okay, so the first thing that I need you guys to know is that inverses are so simple. I'm not joking. There are only 2 things that you really need to know about an inverse, and I'll come to those in a second. It's used in methods 3 and 4. When you see questions that mean methods 3 and 4, if you understand this now, you can giggle with joy because it's like, yay, I get this. This is awesome, okay? Please, inverse functions is so simple, right? It is important to note, and it's so important, a function can only have an inverse if it's 1-to-1, right? The other thing I've written here is that all relations can have inverses. Now, I'll clarify that a bit later on, but remember, anything that's an equation, y equals, just pretty much anything, is a relation, okay? We can do the inverse really quickly of any algebraic relation. That's fine. But it's important to note that a function can only have an inverse if it's 1-to-1. Right, so what's a 1-to-1 function? Well, firstly, if you remember, a function is one where the relation can have a vertical line pass through it only at one point. All right, so in this situation, going back to my trusty y equals x squared, that is a function. I can draw vertical lines all the way through that graph and it will only ever cut once. And as it says here, you can't have 2 y values for an x value. 1-to-1 functions, if you remember, are basically where I draw a graph. If I draw a horizontal line through it and it crosses only once, then it is a 1-to-1 function. In this situation, that would not be 1-to-1 because it cuts twice. Now, we could actually limit the domain of that particular function. So if this, once again, was my y equals x squared, I could limit my domain and say let x only be between 0 and infinity. Now, my graph is 1-to-1. And as such, if it's 1-to-1, it can have this wonderful magical thing called an inverse. Looking over here at this side of my screen, it's so important to note that the inverse of a function is described as f to the minus 1. F to the minus 1 of x. And just to clarify, that is very different. In fact, it's completely the opposite to the idea of finding the reciprocal. Right now, again, if normally we had x to the minus 1, we would know that that would be 1 over x. But in this situation, and the questions generally make it clear, just be aware that f to the minus 1 of x is a way of saying find the inverse of a function. Now, again, when we have to do the inverse of the function, we need to make sure that we know its domain. It'll always be mapped onto R, and we need to know what its new function will be. All right, I'll explain that in a second, but the inverse will have a new domain and it will have a new equation. All right, so Basically, it's really important. This is number one most important thing. An inverse function is where the original function is reflected in the line y equals x. All right, so go back to junior school. Remember when you had to do mirror lines and you did a little box and we did a triangle and you had to work out what it was going to look like in the mirror line, and the first time you drew it, it was like that, and the teacher went, "No, what are you doing, Muppet? That can't possibly be right," and you felt stupid. And then you went away and you thought about it and the teacher told you to count squares and you came up with that and you were really happy with yourself, right? Smiley face. And then, well, the teacher undoubtedly got more confusing and then went, "Well, now let's do a dotted line here," and they do the triangle here, and you went, "Well, surely it's the same, isn't it, there?" And teacher went, "No, don't be silly. What are you talking about?" And then you went, "Oh, okay, I remember." And they taught you to count squares, and eventually you ended up with this. And you were like, "Yay, life is good. I'm so happy I can do maths. I'm a genius." And then for the teachers who were particularly evil, they did this. They did this dotted line, and they put a triangle like this, and then you just fell apart because you're like, "Oh, I don't know. Right? The point of it is, this line here is y equals x. And the inverse is nothing more than taking an original image and flipping it or reflecting it in the line y equals x. Why? Who knows? Who cares? Not interested. I know that to do an inverse of a function graphically, I draw the line equals y equals x, and I just reflect it. Okay, so let's go back. Let's imagine then I've got, here is my line y equals x, and I've got some part of a function. I don't know what it is, but whatever it is, it's got some part of a function. This point here, 1, 3. This point here, let's say 3, 10. This is going to be x, and this is f of x. So I now want to come up with my inverse function graphically. And what am I going to do? I'm just going to reflect it in that line. And so hopefully it's going to look something along those lines. Now remember, y equals x is a really important line. When you inverse it, what actually you're doing is you're swapping your x and y values. What was the x value becomes the y value, and what was the y value becomes the x value. That is so important, all right? And I'm going to write it. Swap x and y values. Your coordinate literally swaps. So what was 1, 3 now becomes 3, 1, and what was 3, 10 now becomes 10, 3. Yay! I've actually just done my inverse graphically. I couldn't tell you life was any more exciting or hard than that. That is it. Graphically, just draw it. Even if they gave me my graph down here, for example, say that was my graph and I wanted to inverse it, doesn't matter. Draw the line y equals x and just flip it. All right, that would basically fail me in an exam because that doesn't even look close, but you got the general idea. Having got that information, how on earth do we find the domain and range of the functions and their inverses? Well, I'm going to go back to this diagram here. Let's rub this out and give myself some space. Look at, let's call it line A, and line B, let's say that's its inverse. Looking at line A, what is the domain? Well, the domain is the possible x values. Well, the lowest x value is 1, the highest x value is 3, so my domain is 1, 3 in square brackets because it includes it. And what would my range be? Well, again, my range is the value, the y values that are possible. Well, the y value, the smallest y value is 3, and the biggest y value is 10. Yay! Now look at line B. And again, answer me the question, what is the domain and what is the range of line B? Right? Well, the domain is 3, 10. And the range is 1, 3. And hopefully you've actually realized that for line A, what was the domain becomes the range for line B. Why? Well, think about it. You've swapped the x and the y values. And the x values stand for the domain and the y values stand for the range, which basically means that if I'm swapping x and y values, I must also swap my domain and range. Mind blown. Ladies and gentlemen, that is the second most important rule for inverses. Wow. Big hint here. Big hint. Sorry, my screen has just moved. Fat fingers. Big hint. Hint, 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 hint. Always find the domain and range of your original function. All right, always find the domain and range of the inverse function. Then, when you need to write down what the inverse is, just swap them. Don't ever try and find the domain and range of an inverse function. It's too much like hard work. You can actually make life easier for you by finding domain and range of your original function, in this situation A, and then just swapping them. Okay, so let's do some actual questions and some examples. Find the domain and range of the function 0, 4 mapped onto real of f of x, x squared. All right, so find the domain and range of that function. So the first thing I'm going to do is I'm actually going to draw a sketch. Please, in all cases, draw a sketch. 0 to 4. Yep, so there's my value of 0. There is my value of 4. I know my function is y equals x squared. There is y and there is x. First question, is this 1 to 1? It is 1 to 1. So 1 to 1, and I'm going to put a tick and a smiley face because I know it can now have an inverse function. Right, I need to know the domain. Right, well, interestingly, and the great news is with these questions, the domain is actually given in the question. It's actually given in the function. Thank you very much. Because I can read these things, I know what the domain is. So, what is my range? My range is possible y values. Well, looking at my graph, I know the smallest y value is 0, but what is my biggest y value? Well, it doesn't actually tell me. No, it doesn't, but you can certainly work it out because you know that your maximum x value is 4. When I put 4 in there, it becomes 4 squared. And so, ladies and gentlemen, there is my range, 0, 16. The only thing I actually had to do that was complicated in that question was substitute the value 4 into y equals x squared. All right, having done that, hence find the domain and range of the inverse function. Now, it's not asking you to graph the inverse function. Thank you very much. It's not asking you to find the equation of the inverse function. Thank you very much. It's only asking you to find the domain and range of the inverse function. So, therefore, the domain of my inverse function, domain of f to the minus 1 of x would be equal to 0, 16. Why? Because I've swapped them. What was the range becomes the domain, and what was the domain becomes the range. So the range of f to the minus 1 of x becomes equal to 0, 4, nothing else. Thank you very much, Mr. Examiner. I'll have 27 marks just for that. Sadly, won't ever be 27 marks. That one, probably 1 mark. But do you see where I'm going with this? Not particularly complicated. So now, we've got to remember that when you're finding the inverse function using algebra, we need to come up with f to the minus 1 colon some sort of domain, not a double arrow, mapped onto real of f to the minus 1 of x equals. So we now need to come up with ways of finding the inverse function. Why? Well, if, again, this is your dotted line, if that's your original function, there is no way that that can have the same equation. So there's got to be a way for us to be able to work this out. Right, well, let me think. Find the inverse of the function 0, 4. Well, actually, we've already done that here. So I now know that my domain of my inverse is equal to 0 to 16, and I know my range is equal to 0 to 4 of my inverse function. So that's going to come in useful in a moment. All I'm going to do is come up with the equation. Remember, f of x equals x squared can be rewritten as y equals x squared. Do you know what? Again, to find the inverse, go back and think about what happens when you reflect in the line y equals x. Do you remember? Well, your x and your y values swap. So actually, that's what you do with your equation. You swap. Where you see a y, you put an x, and where you see an x, you put a y. And mercy. That's your answer, isn't it? Nope, sadly not. Not quite, because function notation needs it in y equals. So I'm now going to square root my value of x, and it's going to be plus or minus. Now, here's an interesting one. We now have two possible functions. This can actually only really be one. Oh, not this one. Ignore that. When we have the inverse of function of x squared, we can only have one. So let's just go back. I'm going to rub this out again, and I'm just going to sketch what this graph looks like. So here we go. Bow, bow. There is my 0 to 4 of y equals x squared. Here is my dotted line through as y equals x. So here's the interesting question. We now have to understand that this is y is equal to plus root x, or y is equal to minus root x. There are two possible solutions. So, first things first, this is where you have to understand what the graph of plus root x looks like. Well, if you remember, it looks like that. Why? That looks pretty awesome. That actually, I'm pretty sure, is going to be my right answer. What does this graph here look like? Well, the negative in front of the function, because of transformations, will flip the graph of root x in the x-axis. So a very quick sketch suggests that actually that graph would look like that. That's not possible because it doesn't look like it. This cannot be possible, so I have eliminated one of my choices. Is that final answer? No, because it says find the inverse of the function, and it's given in function notation. Where it's given in function notation is expected to be in function notation. Well, I've already scaffolded my answer, f to the minus 1, because it's the inverse. I've got my colon. What is the domain of my function? We worked it out in the previous question. Oh, why is my pen not working? There you go. So I know it's 0, 16. Thank you very much. All I need to do now is write in what my actual function was, and that is the square root of x. Job done. So 3 stages to this. 1, find the domain and range of the original function and then flip it, which I've already done here. 2, make sure you swap the x and the y in the formula and rearrange it to y equals. And whenever you get a square, realize you have 2 values of 2 possible functions, which you have to sketch and make sure you choose the right one. And again, I can't impress this enough. Sketch, sketch, and sketch. The more sketches you draw, the better you will be at this. All right, last one. This one here. What is this? The function of, 3, 6 of that, find f to the minus 1 and state its domain and range. Ooh, how exciting. Well, here's a graph actually to help me out. So, my domain of my original function is equal to 3, 6. What is the range of my original function? All right, my range. Well, when I put 3 in, I'm going to get 3 on 3 all squared, which gives me 1. And when I put 6 into my original function, I'll get 6 on 3 all squared, which is 2, which is 4. So my range is between 1 and 4. All right, well, let's just check. Here is my original function. This is my original. And here is my, no, that's not true. So let's just check. Which one's my original? Well, as it turns out, it's this one here. If you're not sure why, sketch this. Use Desmos, use your CAS calculator. Here is my original. Does it have a domain of 3 and 6? Well, it seems to start at 3 and finish at 6. Does it have a range of 1 to 4? It does have a range of 1 to 4. So the first thing I'm going to do, I know that for f to the minus 1 of x, the domain is equal to 1, 4. Because that was the range of the previous one, and the range will now become 3, 6. So that's one thing done. Easy. That's a tick somewhere else. What do I now need to do? Right, I need to now do the algebra. So what is my algebra going to look like? Well, we've been given f of x is equal to x on 3 squared. So I'm going to rewrite that as y equals x on 3 all squared, and then because my x and y values are swapping, I'm going to do exactly that. X is equal to y on 3 all squared. Wow, I'm going to run out of room. Get rid of my square. It's going to become a square root. Oh dear, so I've got to have a plus or minus. X is equal to y on 3. And then I'm going to multiply everything by 3. Now, a word of warning, that does not become 3 plus or minus the root of x. That's a silly mistake. It is plus or minus 3 root x. Once again, that now tells me I've got 2 possible functions, plus 3 root x or minus 3 root x. What does plus 3 root x look like? Well, basically, the root of x is going to look like that. What would minus root of x look like? That would look like that. Which one are we looking for it to look like? Well, we seemingly have this orange curve going that way. It's got to be that. That's not possible. That is possible. So, having narrowed this down, I've now got to actually state its domain and range and find the function. So, f to the minus 1 with a colon of my domain, which we found out to be 1, 4, is mapped onto real of f to the minus 1 of x is equal to my new formula, which is 3 root x. It's the positive. I don't need to write that positive, so it becomes 3 root x. It says state the domain and range. I would then need to go on and say domain is equal to 1, 4, and the range is equal to, what did we say it was? 3, 6. All right. Again, this square root stuff, this double craft stuff, choosing the right one is very, very much used in methods 3 and 4. All right, so here are some shortcuts to make sure you hopefully get these questions right. Always make sure, try that one again. Here are shortcuts to make sure you get these questions correct all the time. Number 1, make sure the function is 1-to-1, and if it isn't, you'll need to restrict the domain. What do I mean by restrict domain? If that's your 1-to-1, if that's your function, you're going to need to ignore it. You need to get rid of that bit so that you can pass that horizontal line test. 2, sketch the graph. Big hint, use your calculator. 3, use the domain to substitute f of x and find the range of the function. What do I mean by that? Well, again, I knew that the domain was 3, 6, so I substituted both those values into my equation. 4, swap the pronumerals in the original function. Yep. That's this bit here that says write down the original function, swap the x and y, and then get them so that y equals, swap the domain and range, and write the function notation. All right, again, fairly swift, well, 23-minute long video, not that swift, on inverse functions, but critically used in methods 3 and 4. Thank you once again for your time. I look forward to seeing you again. It's been so great having you watch this video that I'd like to see you again and again and again. Wow, we could make some amazing maths together. So, if you'd like to, and you'd like to be updated as to when I upload new videos, why not subscribe by clicking the button on the right? Otherwise, if you want to click and see another video created for this type of series, then click the video on the left. All right, well, you have an awesome day, and I look forward to seeing you again.